Yes, hello. Welcome, everyone. Okay. It is my pleasure to announce our next speaker, Atieno Ouma, and she is going to tell us all about generating synthetic data, which I think is a really big problem if you have not enough or not good enough data. So I'm very curious to see how you did this in your field. Take it away and give her a big round of applause.
With this, yeah? Hi. Sorry about that. By the way, my name is Atieno Ouma, not Ouma. Yeah, I get that a lot because I've applied for a number of jobs, and when you get a response, they say, hello, Ouma. But then when you tell Google Translate to translate it, it says, hello, Atieno Grandma. So yeah, it's Atieno Ouma. And today we are going to talk about how you can use synthetic data to develop solutions that are local. Before we go about that, maybe just a quick intro about myself. I am from Nairobi, Kenya, and I work as a software developer at a USAID project called Health IT. And what we basically do, we develop health information systems and data and products around health informatics. So generally, anything data, health information, yeah. And I'm very passionate about backend engineering. We could talk about endpoints any day, anytime. Anything health informatics, again, health tech, and how to use artificial intelligence to improve delivery of healthcare, and also teaching coding. So probably on the weekend, when I'm not obsessing about these things, you'll find me in some school teaching high school kids how to code. And then, of course, I also obsess about head wraps, so yeah. Let's begin with a definition of what synthetic data is before we even look at how we can apply it to a localized solution. So synthetic data is generally artificially generated information. That's it. But then on top of it, it has to kind of mimic the real-world data. So first of all, you have to have an understanding of what the real-world data is before you even talk of synthetic information, how to synthesize it. And when you talk about synthetic data, there are a number of paradigms or like types around the process of synthesis. So we have fully synthetic data. These are data that is fully artificial, but then with the preview of, or context of the real data. And then, of course, you have the hybrid data, which is a mixture of real and synthetic data. And this comes in handy when you have a data set that is missing some features that you might want to add. So you add a set of new features to the already existing features that you have. And then, of course, you have partially synthetic data, which is a privacy-enhanced real data. So if you want to mask away any personal identifiable information, this is your go-to. And just the intersection between them is like, just refers to the process of generation or its applicability therein. And I want to make one comment. Some people might find it controversial, but yeah, synthetic data is not fake data. When you're talking of fake, it's something that is fabricated. But then the whole process of synthesis, the whole process of applying algorithms to generate the information, the whole process, the science applied to generation of synthetic data does not make it fake, because if it is well generated, it actually mimics the real world information. So the keyword here is well generated. You have to have like a well-structured process or standard of generating the synthetic data. And someone will be tempted to tell us, how do they compare? Can we put them on a scale? Yeah, sure, we can do that. Of course, let's start with real data. Of course, it has its advantages and disadvantages. We have authenticity, rich context, the already established benchmarks that are there, of course, the human factor or the organicness that there is to it. But then it also has its disadvantage that, as you can all see up there. And then let's introduce synthetic data into the mix and see how they relate. Synthetic data comes with a perfect fit, but then you also risk overfitting, and then you also have a bit of validation challenges because we don't have standardized benchmarks, of course, and then there's also the potential lack of realism or the organicness, and then also there are some ethical and legal concerns around the use and the generation of synthetic data. But then if you look at our weighing scale, does it depict what is actually real out there? Does synthetic data outweigh real data? Anyone? Does it outweigh? I don't think it does. Because both synthetic data and real data do have a critical role to play when you want to develop data-centric solutions. For instance, you have real data that is incomplete. How do you make sure you're adding the new features that you really need into your information so that you have like a wholesome data-driven solution? So they do complement each other. It's not about which one is better than which. It depends with your context. It depends with your situation. It depends with your local realities in that moment. So next, we'll look at the power of context. Why are we talking about localized solutions? A solution is a solution, no? Yeah, of course, I've developed a model to like evaluate who is eligible for, like, let's say some funding. It's working. Why do we need something local? And to do that, I'll try and put the context around health. Let's try to formulate a policy around maternal healthcare insurance. So we are going to have two profiles to draw a contrast. So the first profile is of Anne. Of course, we have her information, her basic information. We have her age, education, occupancy. Of course, we are formulating insurance policies around maternal health. And these are variables that we might need, or like features that we might need. Maybe look at things like insurance. She is obligated to have it. Look at where she is from. She is from an urban setting. And then the parity, which is basically the number of children that Anne has. She just has one child. So how do you look at all these features when you're trying to formulate a policy around maternal health care? Our second profile will be Sanaipei, who is similarly the same age as Anne. Her highest level of education is secondary school. She's a small-scale trader. That's her monthly income and all that. If you look at health insurance, of course, she has it, but it's optional. So let's look at the Kenyan context because we placed Sanaipei in the rural areas of Kenya. So in Kenya, health insurance is not mandatory. You can choose to have it or you can choose not to have it. And the one you choose to have also influences what services you can actually get. And to be honest, public insurance or like the national insurance sucks. You don't get so many packages around it. If you look at the parity, we have like she has 3 children. So if you're formulating policies around, like let's say, will you cover CS for such a person, you have to look at such factors, right? Because if she's had 3 children and like all 3 children were through CS, you wouldn't want to formulate something around that again. But then there are some factors that are missing from this data set of ours. So far, for the 2 profiles, the data sets are somewhat identical, right? But then if you look at Sanaipei's profile, we do have some things that we are not privy to. Like, we said she's married, right? But yeah, she's married as a second wife. And not just as a second wife. She was inherited by her late husband's brother, and I'll explain this in a cultural context. From my tribe, if you die, your cousin or your brother or someone within your village or your community can marry your wife to keep your children within the community and to keep growing your name and your family. It is a cultural thing. It happens. Does it still happen in the same scale that it was happening back then? No. But it still happens. It's her reality. And then she's also burdened by black tax, which is just the soft-spoken financial responsibilities that your family place on you. So it's not a rule, it's not standardized. You don't know how much this person spends on their family, when they spend it, and how they spend it. So it's very soft-spoken. And then if you look at things like, other than just her personal factors, we have things like infrastructure, the roads, distant clinics, or like how to access those clinics, or the resources in that clinic. And then you have things like government policies. For example, in Kenya, the previous government declared maternal care very free for everyone. But then the current government that we had abolished the whole thing. So when you're formulating policies, you have to look at things like that. How does the government affect the policies that we are having? But then it's not all bad. Actually, it's not. Because there are some local factors you can actually take to your advantage. For instance, it's a payment policy you are formulating, and every Kenyan has access to mobile money, as opposed to like banking. So like 80% of Kenyans can access a mobile wallet through their phone, and not just a smartphone, even the burner phones. So it actually brings the convenience. So you want to leverage on such things. And then look at things like community groups. We call them chamas. Growing up, I used to see my mom go to these groups almost every other week. And these groups just come together to save, invest, give out loans to expand business and such things. So you want to explore how you can use these groups to formulate the policies that can enhance insurance of expectant mothers. And then we also have things like community healthcare volunteers who work within the community, in the villages, with the people. How do you leverage on these people to help you with your policy? And of course, Anne also has all these other factors around her that I'm not privy to. I'm only speaking of the factors that I know in Kenya are happening that can actually influence how you formulate policy. So by the end of this talk, probably you might want to think about what factors affect the Anne in my community, the Anne in my locality that are not usually reflected in other data sets, and how you can actually use it in a later context or at a later time. But then our two profiles are not alone. My reality is not my own reality. There's like a larger population that share the same reality. For instance, in Kenya, which is divided into like 47 counties, we do have some realities that are local to some regions. For instance, we have Machakos, where the main economic activity is agriculture. You might want to factor that. But then we also have prevalence of things like witchcraft. Someone might believe that they have been bewitched or they were cursed. So it affects how long and if they'll even seek medical intervention. So how do you gather data points around such beliefs, around such cultural practices? And of course, you have things like poverty, which is very prevalent in so many areas. When you look at areas like Turkana, we do have nomadic pastoralism. So this basically means the Turkana tribe move from one place to the other in search of water and pasture for their livestock. And then we do, of course, also have poverty, drought, and then we have things like female genital mutilation. It's not as prevalent as it was back then, but it still happens. So for those who don't understand what FGM is, it's basically the mutilation of the external female genitalia for non-medical reasons. And it's actually tied to a number of tribes in Kenya. Is it still practiced? Yes. And actually right now there's a group of people who are cropping up like, let's go back to our roots. Let's go back to what our ancestors used to practice. So they're actually doing it voluntarily, out of will. So how do you factor in such things when you're developing solutions? And in this context that we are in for maternal health. Look at places like Mombasa. We do have tourism as the main economic activity. And of course, mainly to look at is drug abuse. And it's not just drug abuse of drugs like cocaine. People injecting drugs into their own system. So how do you formulate policies that revolve around such occurrences in these localized areas? Let's look at places like Ouma Bay. The main economic activity is fishing. Of course, we do have widow inheritance, as I mentioned. But then there's also a unique practice called sex for fish. And let me be clear, it's not sex, it's not sex work. Sex is being used as a currency in this case. And you might ask, why do you even want to know such things? You want to know because when you wake up in the morning and you see such things in the news still in 2024, prevalence of HIV because of sex for fish, it has a correlation. So you would want to know, what do they do it? Is there a way we can come in and mitigate things like this? Yeah. Having gotten a short preview of some of the cultural activity or cultural practices in Kenya, maybe let's look at the landscape of healthcare data. So in Kenya, healthcare is devolved. Every county is responsible for their own healthcare policies that are not affecting the nation at large. Of course, we do have acts like the Digital Health Act and the Data Protection Act that govern how you go about developing digital solutions and how you go about handling healthcare data. And then we also have things like the interoperability framework that has been defined actually, and we have things like the terminology, medical terminology dictionary that stores the medical terminologies. Of course, we are dealing with digital solutions, so we have to have a dictionary for that. We have repositories for healthcare institutions, and then we have repositories for the insurance companies and how they integrate with other healthcare information systems. But in spite of having all these infrastructures and frameworks in place, we still do have challenges, such as bureaucracy and red tape, incomplete and fragmented data, privatized data, inconsistent data. And all the first four are actually contributed to by the fact that healthcare is devolved. So, for instance, the first point of bureaucracy, I am the person who is responsible for health in this county. If I have some reservation or some interest in a certain area of health and you come with a solution, I'll not let you implement it. So such things still hinder how we do things. So given these challenges, we actually came up with a solution on how we can go about gathering data. So if we realize we don't have the data that we need to develop the models that we want, we do work with at least 12,000 people in each and every county. And when we are working with them, we actually get into an agreement that will get access to their medical records, their family history and genealogy, and they do participate in studies and do medical tests and all that. And what do they get in return? We do cover their medical expenses during this period, and we've actually partnered with a number of insurance providers to make sure that we keep this cost at a low, because when you're talking to your project manager and you tell them synthetic data is the best way to go about it, they'll ask you how much. Like, they don't even want the best of the solutions. They want to know what will it cost them. So, of course, we work with a number of insurance providers to keep our costs at the minimum. And then when I was mentioning certain data points that you might want to look at, some of you are wondering, how does it affect? Things like female genital mutilation, you want to look at what time was it performed, at what age and which year was it performed, and what type was performed and how is it performed. And then you also want to look at access to healthcare post the procedure, and then the obstetric history. You want to look at, has this person ever given birth? If she gave birth, did she have any complications before that? And these are actually things that insurance companies take very serious when you want to sit them down and formulate policies, because they'll tell you, no, this person has had way too many complications during birth, so you cannot put them in the same tier of payment with other people and things like that. When you look at polygamy and wife inheritance, you might want to look at the marital status and history, the number of co-wives that are there, and who is the breadwinner and how is resources allocated in this family. You want to know the knowledge and use of contraception. You don't want someone married to like 10 wives to be having children like all the time. Of course, we do want them to have children, but then it needs to be a bit planned. So you want to look at such factors and how you can help them. And we also want to look at the birth outcomes from such families. And then when it comes to infrastructure, you want to look at proximity, availability of transport, the condition of roads, and access to electricity and water. And then to the most interesting thing that has come up of late, and it's actually a trend, the use of herbal medicine. So we realize people are kind of now ditching the lab medicine, or like ditching the hospitals even in its entirety in favor of herbal medicine. And it's not always that the outcomes are so bad. Actually, some of them are doing fairly good compared to when they're actually taking medicine. We call them lab medicine, or like scientific medicine for that case. So we are currently working with a partner in the health sector to look at how do we incorporate herbal medicine in such therapies or in such treatments or in such interventions, because it's not always that it brings a negative outcome. Yeah. Now let's look at the methodologies we usually employ. We do use two methodologies: simulation models to simulate how processes or how things work. And we do also have generative adversarial algorithms. And this is just an overview of how GANs work. Like, we do have two neural networks, a generator and a discriminator. So a generator just tries to fool the discriminator, and the discriminator is supposed to figure out, am I being fooled in this situation? And the cycle continues until the discriminator cannot determine between real data and fake data. And then once you've gotten your synthetic data, you subject it to a number of assessments and assurance, fidelity, utility, and privacy being among the top. And something maybe just I would like to mention very quick, when you're developing a generator for synthetic data and you're dealing with minority groups or a new disease that you don't have privy to, you might want to add metadata as conditioning information. If this, then this, because at that moment you don't have privy to a lot of things. You don't know how the distribution in the data works. And you'll also want to add Gaussian noise for differential privacy. And then these are just the types of GANs you might want to apply for different types of images, different type of data, sorry. So for images, you want to apply DC GAN, C GAN, or style GAN because they capture the spatial relationship. And it's actually very important in imaging data, and this is one of the things we really struggle with a lot. For time series, you want to use RNN and time GAN, and then for tabular data, you want to use T-GAN, CT-GAN, and C-GAN. So T-GAN is just time GAN series. And then for textual data, you want to use sequential GANs or text GAN. And then for evaluation, of course, you use inception core and Frechet inception, but then you also add things like clinical utility, similarity to real patient distribution, and the performance of the models. We'll not look so deep into the impact, but this has been the impact that synthetic data has had on our processes internally, not on the patients themselves. Maybe just to lessons learned, you might want to look at how effectively do you integrate cultural nuances. Do you go to a place and tell them, no, your culture is outdated. No, you should do this. No. You look at how do you integrate what they are currently doing with your solution. And then how do you foster transparency? And how do you make sure you engage the community such that when you actually produce a product, it's something that they can use and they have a buy-in? And you also look at the socio-political factors and how they influence how people adopt things, especially the political, actually. If the political class does not agree to something, you're not going to implement. You also want to look at how do you adopt the models to different health systems. They vary from place to place, even in the same country, actually. Especially in Kenya, because every county is responsible for their own health system. And then maybe something you also want to look at in terms of data and technicalities is it relevant? Because not in all not in all contexts you need localized solution. For example, if you have data about Kenya and you're implementing something that is generally about Kenya, you don't need to go down to the counties and to the communities to ask a lot of questions. Yes, you already have the data. And then how do you balance generalization and localization? And then do you have the expertise needed? And not just technical. And this is something people often overlook. Even the social expertise, you really need them. Actually, the social aspects are usually the most weight-carrying aspects, because the technical, you already know how to go about generating data. You already know about how to develop models. And then you also want to look at the adaptability of technological disparities. When we started, we developed a mobile app and a web app, and we were developing actually in Nairobi. So when we went to deploy in the village, we realized not everyone has a smartphone. And even for those who have smartphones, they don't buy data, or they don't have access to the internet. So we had to develop USSD instead to cover for the shortcomings that we had with the mobile apps and the web apps. And then can you integrate with the existing system to take advantage of the data that they already have? So if you have partners you can work with and integrate with, the better it is for you and the smoother things will go for you. And then should you anonymize or pseudonymize? So do you ensure that the data is completely anonymous, Or do you structure your data in such a way that you can trace back to the original person? And it also depends. When you're talking about data that, like time series data, you want to look at the progression of this patient during a certain treatment for a particular period of time. You would want to trace back to this patient so that you know how how to go about the next phases of treatment, right? So in that case, you do pseudonymization. But then when you don't want to trace back to that patient completely, you anonymize the data and you apply the Gaussian way of anonymization. And then maybe just my parting shot is engage with reality. Always engage with reality. Your assumption of how things work here might not be the same of how they work where you actually intend it. And this is actually true for people who just sit in cities and assume that the world has changed, everything has advanced. Of course they have, but that's just within your locality. What's happening in other areas. And then also maybe make sure that your data has the functional equivalence for all use cases. Can it be used to test systems? Can it be used to train models? Can it reintegrate back into the health information systems? Not just for model training, because most people just generate it to train models and then that's it. So the quality of it should be good such that it can be reintegrated in and used in other used for other use cases as well. Yeah, that's it. Any questions?
All right. Thank you so much, Atieno. Are there any questions? I see a question at the back. Yeah.
Can I answer? Oh, okay.
Yeah, now, sorry, if you heard the question, you can answer, but if...
I'm not so sure I heard you correctly. Just repeat it.
Yeah, so I was asking that we also deal with synthetic data and also real data. And a lot of the times what happens is that the real data is more unreliable than the synthetic data because there can be bad labeling, bad annotation, users can lie on the type of data that they fill. So have you also experienced this and how do you combat this when you fit models, for example?
Yes, we have experienced that, but then our way of working is we work with these people in the community, right there and then with them. So other than them just filling questionnaires, we do some observations ourselves. So we work with them, the data we collect that involves filling of questionnaires is very limited. So we mostly like it that when we get their previous medical history, of course, they are not the ones who are responsible for generating that, so they can't lie about it. We like working with them such that we do medical tests with them. So it involves a lot of monitoring during the data collection process. So we make sure the time we spend during the collection it guarantees us we get like very quality data. And of course, there's the problem of annotation because sometimes we also get data from other places that we need to annotate. We do have softwares that help us with the annotation, and we also work with quality analysts to look at the quality of the annotations. But then when it comes to that, it's very hard to tell how, if like the way it's affecting the quality, if that's the right word to say, yeah.
Okay, thank you.
All right. Other questions? Yeah.
Hi.
Hi.
So I know almost nothing about generating synthetic data, but there is a use case I've run into before where people were very interested in developing synthetic data, but some of the fields in the real data were basically open form, right? People could just write down different kinds of information in plain English or Dutch. Is that even something reasonable to synthesize? Just understanding what the field is for, but generating synthetic data as though someone was writing something down in that field? Or do you think it's a necessary step to extract the structured information you want from that field first, and then try to synthesize that extracted value, if that makes sense?
Sorry, if I heard you correctly, you're asking if it's recommended to?
So, yeah, let's say I have a free-form data
Yes.
field where I ask someone about something related to their family history,
Yes,
maybe.
yes.
Is it feasible to synthesize that field itself as though someone was filling it out, or do we need to extract the information from the real free-form data field first, structure it into like a structured tabular data set, and then try to synthesize those values?
Free text is actually one challenging thing to work with, but then you have to extract it. And for us, working with the medical, the dictionary for the medical terms actually helps us. So we do work with some LLMs that actually extract the medical terms and then just plug them into our columns or like our features that we want. So it's advisable to extract it because with a sentence, it's too hard. And then people describe things differently, so you also have to like have a person who knows. Someone might give you a sentence that basically describes one medical term. So, yeah.
No, that makes a lot of sense. Thanks.
Other questions? Yeah.
Hi, thanks for the presentation. I have a question about the sample. Like how, based on what you have decided the size of the sample you have and how you distribute it across like Kenya?
We have metrics that we use to distribute how we scale that data. So we have a system that decides how it's scaled and how we take care of outliers. So it actually depends on what data we are capturing and how many people we are involving during that time of capturing the data. But we do have a metric system that we are using to like scale up the data. So we don't just scale it randomly because there are things like outliers you'd want to look at. In as much as we love seeing outliers when you're collecting data for synthetic data generation, you also want to be very keen not to scale that outlier so bad that it's like the norm or like the distribution. Yeah.
Thank you.
Hi, this is very interesting. Thank you for the talk. So I was wondering, this sounds very much localized indeed, and I'm guessing there is like a lot of work and resources involved in doing this type of research as well. I wonder like if you have any way of like checking, is there any type of drift, for example, like some type of concept drift in the models when in, for example, in a specific local area, some new thing happens, for example, an outbreak of a new disease or something that kind of change the parameters of like how the outputs, how the results would look like. A policy would change, for example, like majorly by some like big event that's happening in that area. Do you do like extra research or update the models? Like how would that work?
It depends. Things can change, but then sometimes it does not immediately affect how your models should perform. So you look at the long-term effect of this change, and if you really need to retrain your model, or you really need to go back and collect information to retrain the model. So it actually depends. Yeah.
Okay, thank you.
Time for one more short question, if there is any. Yeah. Oh, my colleague is closer.
Thanks for the presentation. It was super nice. Do you plan to share this data set somehow, since now it's synthetic data, or no? Because it's very localized, very interesting as well, so I was wondering.
Sharing the data sets, you say?
Yeah.
Oh, okay. So the data sets are open sourced, but within the players in healthcare within Kenya. But then it's open to people who like request for it. Yeah, so maybe I can plug you in with the right people who can actually give you access. But then if you are a healthcare player within Kenya, it's very much open, and we do share it across, because I might have a data set that you need, you might have a data set that I need. So it fosters that collaboration in-house. But then we also open it up to people, but we have to know who's using it and why they're using it. Yeah.
All right. Thank you for all of your questions. And once again, thank you so much for your nice presentation, Atieno.